Hello, everyone. A couple of you are connecting. Just give you a minute. Okay, good morning, everyone. My name is Anand Rao. I'm a professor, distinguished service professor at the Heinz College of Information Systems and Public Policy at Carnegie Mellon. What I wanted to do today is talk a little bit around AI. I'm sure no one has heard about that term in the recent past. Just kidding. So AI in action. So we have heard lots of it, especially over the past couple of years. But AI, as many of you might know, has been around for quite a while, right? 60, 70 years or more. We wanted to look specifically today at what are some of the strategies for scaling AI solutions. So AI is moving very much from being a research area to very much being part of every enterprise, every organization, every consumer, right? So it's essentially becoming ubiquitous. And how do we turn that concept into reality? It's already happening. And over the next decade or couple of decades is going to be the AI decades, where more and more of AI is going to find its way into our life, both as an end user and also at the corporate level. So I'll focus much more on the corporate side of things as opposed to the individual side, but we are all experiencing that. So very quickly, a little bit of a background around myself. I've been in artificial intelligence or AI for almost 35 years now. I started my PhD around 1985, completed around 1988, 89 at the University of Sydney, and subsequently was working as the chief research scientist for Australian AI Institute. And that was a spin-off of SRI International in the West Coast, and did a lot of aerospace and defense work. Then moved on to into the business world after completing my MBA. Spent some time in London and then in Boston, very much focused on strategy consulting, approximately for a decade before AI started coming back in 2007, 8, and then started working more in AI for the business world. The company I was working was acquired by PwC, and eventually retired as the global AI leader for PwC, working on helping our clients implement AI systems, develop the talent, and also working more closely with our global colleagues on national AI strategies and responsible AI and so on. So I have experience both on the corporate side and a little bit around the public policy side as well, and research side before that. So a year back, I joined Heinz, and I teach various courses, one of them being Operationalizing AI. How do we take AI more from a research area to enterprises? Again, given my 30-year background in the enterprise, been very much focused on what are the ways in which we can scale AI, bring the engineering discipline into AI, and some of those. So that's what I plan to talk over the next 60 minutes or so. Feel free to interrupt. So I may not be able to see it, but David has agreed to just interrupt me and ask whatever questions. So this is the sort of plan. Not going to go through it step by step, but we'll cover operationalizing AI, various aspects of it, then cover some of the risks of AI. I want to present a very much a balanced view. There's opportunities, but there are also risks, and we need to manage that for societal good, right? So we'll cover all of those aspects. And then just one slide, a little bit of a peek into the future is what we'll do. So again, I don't need to say how fast AI has been growing, and just a few tidbits here. Most of you might be aware of it. So ChatGPT was one of the fastest to get to 1 million. It reached 1 million users in literally 5 days. And then it went on to achieving 100 million users in 2 months. And then, of course, as of July 2024, the latest year I could get the figures, you see that there has been 2.44 billion visits. These are not users, these are visits, the number of people who have visited the ChatGPT or OpenAI site in that single month. So you can see the magnitude. Again, I'm mentioning ChatGPT, but there are a number of others in a similar league, including the Microsoft, the Google, Amazon, Anthropic, number of other players as well. But you can see the popularity of it and how people have been adopting it. So AI is growing very fast. That's not just in the consumer world, right? So the 2.44 billion people is in the consumer world, but also very much in the business world. So here's a quick chart from McKinsey. We have been tracking the adoption of AI in enterprises. Again, they define it by at least one business function, 2 to 3, 3 to 4, and so on. You could go into all of the details, but you can see that the adoption of AI from 18 to 22 was relatively flat, 4750. But then since the generative AI has come about, there's an adoption of an overall AI as well as the generative AI. You can see the numbers here. So here we are talking about enterprises. So everyone wants to do AI, whether it's an enterprise side or whether it's the consumer side. Now, so what are the challenges? So generative AI is growing fast across multiple disciplines, as you can see here. Again, this is a slide from Bain now, and which looks at various areas of software code development. We are talking about information systems, and the way AI is penetrating into the technology area, into information systems, is huge. And you can see that in these graphs here, in addition to customer service, marketing, operations, IT, and so on, right? So you can see the various groups. Although there's a lot of interest on what and how AI can help, there's also, as we'll see later, a number of hindrances on how AI can actually be adopted. So there's a talent shortage and so on, which we'll come to in a minute. So now what exactly is this generative AI? So some people might think, oh, generative AI is sort of new. It just came up from somewhere. That's not quite true. As you see from this diagram, so AI is a very broad umbrella and it's been around. So 1956 is when the word was coined. Arguably, people have been working in the pursuit of intelligence and intelligent machines for quite some time before that. But the word AI was coined in a Dartmouth conference in 1956. And ever since then, it has been improving and getting better and better. There have been various stages of AI. And I've been fortunate enough to at least have 35 years of that, almost half of that AI development. Machine learning became very popular, is still very popular. There's a aspect of machine learning, which is deep learning. And that's where the generative AI has come out of the deep learning advances. Now, the fundamental difference between all of those previous waves and this generative AI is the other ones required data scientists to use. So you required Python programming. You needed a good background. So now what is happening, generative AI has essentially opened up the aperture to pretty much anyone and everyone because of the voice enablement, images, and then text. Anyone can converse and use that AI. And that's what has made it exciting. And that's what has made it essentially very much a common person's tool. Now, I said there are some challenges with AI, and you can see it in this slide here again from a very recent survey that they conducted. It shows that the company tech platforms are not yet ready for generative AI, and they lack the in-house expertise. And companies don't have the data ready for generative AI. So those are some of the top things that organizations are seeing as they start adopting AI. And that sort of underscores the importance of operationalizing AI, of essentially training people, training all of you, right? So training the much larger workforce, which is already doing IT or customer service or operations, training them to be much more AI literate. So on that note, as part of my college, Heinz College at CMU, we are going to be starting from next fall, a Master of AI Systems Management. Again, we have been doing the information systems management for a long time now, and this is a new degree around Master of AI Systems Management. Again, very much focused on how do we take AI and essentially take it across the broader enterprise world, corporate side, as well as the public sector side. So that's the aim of that program. And what you're seeing here is literally a couple of my courses and just a bird's eye view of those courses. So these are all semester-long courses that I teach at Heinz. Now, let's get into what do I mean by this sort of word operationalizing AI. And you'd see here, I try to define the word so that there's no confusion on what it is. And you can also see it is sort of very holistic. So operationalizing AI is a framework and a couple of keywords for scaling, right? So the key emphasis here is scaling. And then scaling what? Scaling AI models to AI systems. Again, there's a very deliberate use of models versus systems. People are very used to building machine learning models and AI models, graph models, various types of models. The models tend to be very much isolated, and we have studied, I guess, and taught people very much around data science and how to build these models, how to validate these models. But now what's happening is these models are essentially being embedded in any type of software, whether it's a customer service system, your general ledger system, legal system, biomed system, doesn't matter what system that you're using today for doing your work in any industry, AI is getting embedded in those. So it's not just so much the models, how do these models interact with the software, and also how it interacts with the humans and the data. That's what I call the AI system. So it's the model plus the software code plus the data, and the humans using those are what we call as AI systems much broadly. And again, to generate the full business value, the emphasis is on business value, not just the technical characteristics like accuracy, precision, and recall. Those are important, but at the end of the day, if you have all of those, but there's no business value, there's no point in doing it. And then you see a number of adjectives there: strategic, ethical, sustainable, and so on. Those are all essentially showing how holistic it is. So you need to worry about the financial aspects, the operational aspects, the ethical aspects, all of those compliance aspects. And that's what operationalizing AI is. It's not a silo. It is something that integrates across all of the silos, but then having a very disciplined way of doing it. So that's what we are calling operationalizing AI. And that's a very big part of what we are teaching and what we will be teaching as part of this new AI systems management. And again, you have more details there. So it touches pretty much all aspects, but very much from an AI perspective. So those aspects are very common for digital or information systems, but we will be tackling that very much from an AI perspective. Just sort of keep going on here. So one of the things that people say, yeah, that's fine, operationalizing AI. So what's a great deal about it, right? So now here's a very quick slide. I know it's a very busy slide. I'll just sort of point to a few things here as to why operationalizing AI is challenging, and why, as you saw some of the charts, companies are, I would say, still struggling with it, right? So very few companies have really jumped into it with full force. There are a couple of companies who have been trying it. The tech companies, obviously, given that they are designing these systems, they are much better at adopting it. But then, of course, there are a number of financial services, healthcare companies that are still in the process of adopting it. Couple of challenges. So one is what I call as the ROI challenge. ROI is a challenge for any new technology, but specifically for AI, where it becomes challenging is that now you're comparing the human performance, comparing the AI performance with respect to the human performance, right? So when we say AI is 95% accurate, it's usually 95% accurate with respect to whom is what we generally ask, right? So it's with respect to human beings. Now, which human beings? Let's say you go into a insurance company, underwriters, actuaries, they're all very specialized people. Now you say, oh, the AI is 95% accurate to underwriter. Which underwriter? Your expert underwriter, your top 10% of your underwriters, all underwriters who just joined yesterday into the workforce, they have a very different experience profile and expertise compared to someone who has been doing that job for 35 years. So where are you? Which human are you comparing? Humans themselves can be very variable in the way they work and make decisions. So when and how are you comparing them? So that becomes a challenge. And it's also a challenge, not just from a technical perspective, but also from a psychological perspective as well. So we generally, as a human species, haven't really recorded all the decision making. Now, if AI is meant to improve decision making, do we have a good decision log of all the decisions that we have made for the AI to inspect and say, hey, you did well here, and let me imitate that here. I could do better, so that we are training the AI with respect to us. Unfortunately, it's not there, right? So those are some of the challenges. Again, I could spend a whole hour talking about ROI challenges. Now, the other challenges that you see on the right-hand side here, it's the mindset. So data scientists and the AI scientists are very much in a discovery mode and exploratory mode. Software, IT, information system software has grown more from an engineering discipline. So people know what to do. They break down the problem and do. It's not that the data scientists cannot break down the problem, but there is still a mindset change. They are like true scientists trying to discover a pattern in the data. So they need to be given enough freedom to be able to do that. So if you start putting them under constraints like what we typically do in an agile cycle or a software engineering methodology, then they won't shine. So there is a mindset difference. Now, that leads on to the convergence challenge, where it's not just software doing its own, or data scientists doing their own, or data engineers doing their own thing. They're all coming together across all different stages. So you can't identify now very clearly that's code and you don't need a model here, right? So they're all merging together, converging together. That poses challenges in terms of people, talent, skills, what they have been trained, what their methodologies are, right? So all of them have established methodologies with the data engineering, software engineering, and AI or data science is the new kid in the block, right? So they have to adjust, others have to adjust. So there's a whole convergence challenge, which leads to the skills. The processes are different, the technologies are different, and of course there are a lot of ethical challenges, right? So there's a number of challenges very unique to AI and operationalizing AI, and that's what makes it harder, right? So yes, we understand AI needs to go into the engineering discipline, and that's what operationalizing AI is doing, but there are a number of challenges. So how do we address those challenges is what we typically talk about. And again, bringing some of the rigor that we have been used to in the software engineering side, in the information system side, into the AI, right? So, and balancing the exploration with the exploitation. So what we typically do is look at the AI system lifecycle, just to underscore my point around the difference between AI models and AI systems is as a chart here. So this is directly from DoorDash. I'm sure many of you are familiar with DoorDash and probably have used DoorDash. And this is a diagram from their blog here. And if you actually look at this, there are a number of boxes there. There's a front end, there's a middle end, a consumer service, and there's a payment service, all of those different boxes here. Now, the interesting part here is the AI models can actually be embedded in every one of these boxes. It's not that it's there only in one place. Now, just as the software engineering world has taken a monolithic code and split it into microservices and what people call microservices architecture, models, machine learning models, AI models also should not be thought of as one big gigantic model. Of course, ChatGPT and other similar ones are gigantic models, but now what you're seeing is some of these code are being embedded. The exact decision that is being made becomes essentially a call to another system where it gets that decision from. So it's embedded pretty much everywhere in the system, as you can see from this particular diagram here. We'll come back to what DoorDash is doing and how they are sort of scaling. It's a very good example of difference between models and systems. So now we are not talking about just one or two models here. Literally, they have around 38 models embedded across this entire value chain over here. I'll just do a few more slides and then I'll stop, and then we can take a look at these questions. And of course, when we look at operationalizing AI, the AI, obviously, machine learning models and AI have gone through evolution. So more like, I would say 2010, 2015, things were more standalone, right? So you would have a prediction algorithm, you would bring in the data from your data warehouse or your data mart, make some computations, whether it is segmentation, a recommendation, and then that would be used by humans or consumers and so on, very much a standalone mode. And then we started moving into, hey, standalone mode doesn't work. We really need it real time. We need to be able to query it real time. And that's how essentially prediction as a service came about in the late 2010s. Now where we are going is very much a model factory, right? So there are a number of companies which are essentially breaking down the models into very small pieces, very decisions that is being made, connecting data pipelines, so they're getting streaming data and then making those decisions on the fly. So imagine DoorDash, Netflix, Spotify, all of these kind of companies that are very much in the consumer space, they are operating very much at a continuous mode, continuous learning, continuous deployment, and essentially building large number of models. Models are more like function calls now, but they are essentially using a certain pattern from a data, right? So that's what makes it a model as opposed to just a function in a software code. And this evolution is what many companies are going through. Most companies are probably in the middle stage, and they're trying to make the jump into model factory. And that's when you really need more rigorous systems, and you have literally hundreds of people working on it rather than just a half a dozen data scientists in small groups working at it. So you're really trying to scale the people, the process, and the technology with which people are building these systems, and the scale at which we are building. Very simple diagram here, and then we'll go into the details. So the way we are looking at it is not so too different from the software engineering. Again, we don't have to make whole scale changes. So we have been doing these things with IT systems, computer science systems for the past 50, 60 years. So we don't have to do anything drastic, but we do need to adapt it to the way AI works and the way AI ML models work. So we look at it sort of four phases here. They look like waterfall, but they can actually be interleaved. So there needs to be a little bit of a waterfall method because of the scientific quest. But then once you bootstrap it, you can really run an agile cycle. And we have done that in my previous firm and help clients do that as well. So you basically have a scoping phase, which is essentially where different groups come together, decide whether a problem is an AI or not. Again, we don't recommend that every problem needs to be attacked by an AI. So there are very simple solutions. It might be a people or a process change. Only when it becomes AI, you go on to the next stage where you get the data and discover the model or discover the pattern that fits the data. Or modify or fine-tune your generative AI model to satisfy whatever decision that you're trying to make, whether it's a recommendation or a chatbot. And then you obviously have delivery, where you're actually scaling the system to be used by hundreds and thousands, and as we just saw, maybe billions of people. And then you need to continuously monitor it, especially in AI. Things are moving so fast that even for professionals, it is very difficult to keep pace. And in fact, without using AI, I don't think anyone can keep pace with the amount of material that is being generated today. Arguably, maybe some of that is AI generated, but even otherwise, even human generated one plus AI generated, you can't keep pace if you're not using some of the tools that are now available from Gen AI to keep pace with what's happening in the world, right? So we'll go a bit deeper, one step deeper into this. And here you see basically the scoping, discovery, delivery, stewardship, call it value everywhere. And then that steps in, that breaks down into multiple smaller steps. As I said, value scoping is very much around business and data understanding, and then doing the solution design if you think it is an AI problem and can be tackled with AI. Then you go into the discovery phase. That's a very typically a data science phase where the software engineers are doing the agile cycle. So having understood what the problem is, what kind of model we want to build, the data scientists can go into their own agile cycle to build these models and validate these models. Again, the specification for what they should be should come from the business at the value scoping end, but then these people are building the model, and at the end of the stage number 5, there's a very conscious decision. Is this model fit for purpose? Should be deployed? Does it have the right accuracy? Is it biased or unbiased, right? So are we able to remove as much bias as possible? You can't remove everything, but is it it okay to be deployed? Is it explainable? All of those criteria go in, and then you go into the value delivery phase where you're deploying it, where you need to worry about what is the latency, how often are you going to be retraining the model with newer data, and what about the people? So if people are going to be using these systems in a human in the loop, how are we training them? How are we gaining the trust of those humans? That's all the transition execution. That's the people side. As I said, when I say AI system, it's not just the data model and the software, it's the interaction of the people with that, right? So how do you gain trust from the people? And how does the AI know which human to trust for which decision, right? So there's a range of, there's a huge variability in the way humans perform, even within a certain department. How does the AI know? How do we teach the AI to be better? I mean, AI can also be used to reduce bias. How do we teach the AI to reduce bias in the human decision making, for example? And then the value stewardship, where you have to continuously keep monitoring it, and there are certain thresholds that you do look at, and then periodically, maybe every quarter, every year, you decide whether you want to keep the system, retrain it, or go with a new technology. All of this is happening, and of course, you can see the iterative cycles. It can go across, and this is a looping circle here. So scoping, discovery, delivery can all go back into the previous stage or the next stage, right? So, and you see the different stages here, and also the different teams. So we might come back to it if time permits as to who all are involved. And you can see early on in the scoping, it's more business teams involved, data scientists involved in the discovery. Delivery tends to be both software, ML engineers, and AI engineers in the value delivery. And then stewardship tends to be more compliance, operational folks being involved, right? So various groups of people. It's not just data scientists. It's a much larger collection of people who are being involved. So let me take a pause here. I know there are a few questions here. Let me just go.
Most of the questions are focused around the AIM degree.
Okay.
So I've managed to handle all of those for now.
Sure. Yeah. Thanks for that. Any questions from the audience? If not, I'll keep moving. I'm just sort of moving a little bit into generative AI. So obviously that's the thing that everyone is interested in. So give a little bit of a taste of generative AI. Okay. If there are no questions, I'll keep plugging on. Generative AI. So one of the biggest things in generative AI is what are called foundation models. You may not have come across foundation models. You might have heard things like large language model, LLM, or large vision model, large speech model. So instead of calling them large of every one of those, foundation models are a shortcut for doing that, right? So now you're also looking these days, at least, what's something called multimodal models, which means that it's not just specialized on text, not just specialized on images and voice. It is all put together. So foundation models are ones which have been trained with all kinds of data, as you can see there. Now you have the core knowledge. You can then adapt it for various tasks: question answering, sentiment analysis, information extraction, and so on. Now, the power of what generative AI is offering in the earlier days, even 5 years back, 6 years back, when we were building AI models, we had to pretty much build everything from scratch, get the data, cleanse the data, build the model, verify it, deploy it. You have to do, every organization had to do everything from scratch. Now, with the advent of generative AI, what ChatGPT, Anthropic, and others are saying, hey, you guys, you enterprises or you consumers don't have to build everything from scratch. We are giving you something where we have trained it with all the internet data or Wikipedia data or all the image data, so that now you can just build on top of it. Just as there was a revolution in open source code, where in the 90s, I was pretty much writing every piece of code myself. There was no GitHub, right? So for those of you aware of GitHub and packages and open source packages like scikit-learn or pandas, we don't have any of those. So everything that you wrote, you had to write from scratch in Python. Python was not existent then. You used to do Lisp or Prolog or C++, Java. You had to build everything from scratch. And then in the 2000s, that changed with all these libraries being available and GitHub sources and other things being available. So you were building on top of someone else's code. Again, initially, people are very, very hesitant. How can you trust someone else's code? Can we really build it? Shouldn't you be building it yourself to be really sure? Yes, some of those concerns still remain with a small group of people, but largely people have embraced that I can build on top of someone else and the open source. So that we are seeing a very similar kind of a evolution here, where these foundation models are basically saying, hey, we have taken the trouble of collecting huge amounts of data. And of course, in the case of some of these large language models, a lot of compute, which you guys don't have, or even enterprises don't have that kind of a compute. They have done that. So now, of course, you can build on top of it. Of course, they're going to charge you for that, for every function call, but that's the reward that they are reaping for all the investment that they have done. So that's the critical thing. And once you have that foundation model, you can use it not just for generative tasks, but you can also use it for prediction, classification, and so on. And that's what is happening. So even though people call it generative AI, yes, it can generate, but it can also do other things. So it's a somewhat of a misnomer. Academic world generally doesn't use generative AI. So we talk much more about large language models or large vision models or multimodal models, but the word generative AI sort of is stuck there. Now, when it comes to the life cycle, as I said, in the earlier days, we were doing data extraction, pre-processing, model building, all of that model-related work. Now, what the Anthropics and the Google and OpenAIs have done, they have said, hey, we are already giving you a pre-trained foundation model, which does most of that. We have taken the data, cleansed it, and done all of that. So now we can essentially build off what they are giving, but then we still have things to do, right? So we still need to select the model. Do I go for a proprietary model like OpenAI or Anthropic's Claude model, or should I use Llama, which is open source, or Mistral, or any number of the hundreds of open models? Which one is better? Should I go with a large language model, or should I go with a small language model? Should I go with a 7 billion parameter model or a 60 billion parameter model? Those are all choices that we can make as enterprises, and that's the model selection. Once you get the model, then you still need to adapt it. As we saw there, it is sort of very generic, the foundation model. You need to say, oh, I want you to interpret legal in a certain way. I want you to interpret medical knowledge in a certain way. I want you to adapt to my data, my corporate data, proprietary data, which you don't have access to, but I'll give you access so that I can ask questions around that, right? So that's more model adaptation. And then, of course, we need to have a metric around how are we evaluating these models, right? It's fine for the generative AI to print out or spit out nice marketing letters, but what is your criteria for quote unquote good marketing letter, right? So, and people will say, oh, I can tell you when I see it, right? So, but that's not good enough, right? So you need to translate that into what constitutes a good letter or a good art, right? So now it's essentially forcing us as human beings to define what goodness is, what art is, what creativeness is, right? So that there is some kind of a measure against which we can measure. So this again goes back to my ROI challenge, where we need a baseline, we need a definition, we need a way of evaluating it. Otherwise, everything goes, right? So which could be dangerous. So that's the overall cycle as we looked at the model life cycle. And pretty much these things are iterative. So and most of the startups here might try it out on some of the proprietary models, and it's very quick to prototype things there because of the user interface and the compute power they give. Once they develop something, then they might go open source and build it on their own, right? So they don't have to spend a lot of money paying to the open AIs of the world, right? So they are balancing both sides. So there are a number of ways of doing this in an enterprise world, in a startup world. Again, a more detailed slide around the model selection. So I'm going to skip some of those. And as I said, way people adapt models are through prompt engineering, retrieval augmented generation. Prompt is just pretty much, I think, what most people are used to, where you just ask a question and you get the answer. Depending on the way you ask the question, you might get a better answer. And trying to find out exactly what kind of question you need to ask so that you get the best or optimal answer from your point of view, right? So whatever that is that you want. And there are various techniques, and that's prompt engineering. So retrieval augmented generation is all these open AIs and Anthropic have been trained on externally available data, but now I'm a bank and I want to make my customer data available, my regulations available, my policies, and I want to query them. So how do I do that? So that's where RAG comes in. You can still have all of that information locally with you and then still query them to get the answer. So how do you do that? And then, of course, fine tuning is another way where you're essentially going and changing the internals of the model to be able to do better. So now I'm going to check, given the time, I'm going to go maybe I quickly past a couple of these just to give you an example of what scaling means. And then I'll spend maybe some time around 3 and then close it, right? So given the time, I may not be able to do full justice to everything. And that's what you would do in a full-fledged course. I've got just a few slides from here. So value scoping is very much the business area. And that's where, again, we have split it up into sub areas. Now, a couple of quick slides. So I said AI is pretty much there in every industry sector. So I pulled out things which are probably not very common. And the common ones are obviously financial services, healthcare, pharma that you see on the right-hand side, even in precision agriculture, right? So that's a huge area where AI is being used extremely well in pretty much calculating and predicting everything, right? So from the time you sow the seed, when to sow the seed, how to fertilize, how much to fertilize day by day, how much, when to harvest, or how much yield we'll get, right? So everything can be predicted. That's what precision agriculture goes. So these are just industry sectors, and then functional areas, right? So whether it is operations, data, IT, risk finance, or the front end, which tends to be more the creative side, research and development, marketing and sales. Doesn't matter whether it's on the creative side, whether it's in the mundane administrative side at the back office, it's on the operational side, AI is there everywhere. So just sort of emphasizing the point that AI is being used everywhere. So there'll be multiple use cases. So when you go into an organization, one of the things that we teach our students is how do you think about it from an organizational perspective, from the business metrics perspective. You can see the business metrics here. And as I said, operationalizing AI is more about business value. So what business values can you get from the AI? And again, there are various frameworks. I'm not going to go into the details here. What do we automate? How do we automate? How do we augment, right? So we still want humans. And again, there are various reasons, right? So it's always much tougher and more expensive to automate the last mile. And it's much better to use humans. And there's another reason, of course, the fundamental nature of humans, they derive their identity from their work. So you don't want to dispossess them of their work and their decision making. And that's something that needs to be thought through as well when you think about these augmentations. So you want to remove the mundane work, but you still want the human thinking to come in. How do you organize for that, right? So that's the framework. And then students essentially come up with various canvases. So these are, if you like, more like specification in the software world, where you starting to specify for each one of those AI use cases. Literally, there are hundreds and thousands of those, of these use cases by industry, by functional area. Some of them are already existing. There are literally hundreds of things, these things documented. And so you draw upon that to essentially look into the organization and come up with the use case, the story. How does it impact the person going to be using it? Where does the data come in? And what is the business value? All of those things. And based on all of those use cases, you start prioritizing. Essentially, you're helping the corporates strategize and say, hey, where do we spend the money and what is the value for it, right? So you see effort and impact, and each one of those circles is a specific use case. You look at the costs and benefits, hard costs as well as soft costs, hard benefits and soft benefits. So the benefit side of the equation, the cost side of the equation, and then of course the resourcing. And then you produce a roadmap, right? So of what do we do now, the next 3 months, 6 months, 1 year. I'm hearing a here. Sorry about that. And here are some of the specification templates here, right? So again, you can go from the very high level business point of view to every model, what needs to happen. So that's what this image shows. Now, skipping a few of these, one example I want to give, then I'll go into responsible AI. As I said, is DoorDash. As we all know, DoorDash is what they call as a three-sided marketplace. So obviously there are consumers who are ordering things from merchants. Let's just for now, let's keep it restaurants where it gets used quite a lot, right? So there are restaurants who are delivering menus and then or food, and then consumers want it. But then there's also the third player who are the dashers. These are independent people who are essentially on a bike delivering the food from point A to point B. And now there's obviously synergies between all these three, and that's why it's a three-sided market, right? So the more consumers there are, the more restaurants would come into the ecosystem. So the more consumers and more restaurants you have, the more dashers you need, right? So people who are delivering the goods, right? So, and with more dashers, you can guarantee the time for the consumers, which makes it easier for the consumer. So the consumer demand increases. So there's a virtuous cycle with all three feeding each other. Now, so when we talk about scaling, this is a very specific example, and you can see the source here. The DoorDash folks basically talk about how they scaled in a period which we all are very familiar about, right? So you can see the period there, March 2020. DoorDash had two models, and they were making 1,000 predictions per second, right? So prediction is how long will it take to go from point A to point B? How long will it take to prepare this pizza, right? So they had to take all of those numbers in and then appropriately schedule and inform the consumers when it is, and inform the restaurant as to when the dasher will be coming to pick up, all of those things that they had to coordinate. But each one was being driven by a model, and there are two models making 1,000 predictions. Now, fast forward literally just 10 months, I guess, in January 2021, they had 38 models, and they were doing 6.8 million inferences per second. So when I talk about scaling, I'm talking about scaling of the models. There are more and more models doing a number of different things, as well as the number of predictions that you are doing per second also increases. So every model's output increases, and there are also more models. And again, sometimes people in traditional industries have this notion, oh, there are maybe half a dozen models, maybe a dozen models. No, there are literally hundreds of models that are being deployed, if not thousands of models, just as what is a function, right? So you could have thousands and hundreds and thousands of functions. So models are essentially getting very similar, which essentially raises the challenge of how do you manage all of those? How do you build those? But then how do you manage those? Again, we all know that this was the COVID period, right? So the authors actually go through what did they do at every specific stage. And interestingly, there's no silver bullet answer. There are a number of things that you need to improve the accuracy, improve the latency, prevent the models from crashing and consuming more resources. They walk through all of that, which we don't have time to walk through, but we go through extensively in the class. And then the results are apparent here, right? So again, connecting it back to the ROI, if you just look at the period between 2020 and 2021, you can see the rise of the market share of DoorDash, which is the red line there. And it's not that this market did not have any competition. You see Uber Eats there. So again, a very well-known company, very, very good at data science as well. But these folks were essentially beating them and gaining market share, right? So between 20 and 2021, Uber Eats got a little bit of a share, but not as much as DoorDash. And this trajectory has been continuing for them, while others really didn't do much, right? So Grubhub and a few others. So you can see, I'm not attributing everything to the what they did in the AI, but AI was probably one of the bigger aspects. The scaling of the models was definitely one of the aspects where they were able to keep up with the demand. Of course, the demand was huge. The demand was available for everyone, but they exploited that demand situation by gearing up their AI, by scaling their AI. And that's what we talk about when we talk about scaling. There are a few companies that do that well: DoorDash, Spotify, Airbnb, Netflix, and so on. But what you really need is every company to be doing it. So that's what we talk about as this. I won't go too much into the the stewardship here, it's more about monitoring models. The systems fail, but models, in fact, decay, which is an interesting contrast. So there's a lot of work that has gone into failure, reliability, resilience of software systems. But now when it comes to models, it's a more a gradual decay or maybe an abrupt decay, right? So that's what you need to do. It's not that there are no theory behind it, some of the things that we read in operations research and other fields of science, but we need to adapt that to what we are looking at in the models. And that's what people have done. So I'm going to skip some of these slides. So, for example, one of the key things that people need to look at is drift. So the drift could be from the data side. So the model hasn't changed, but people's behavior has changed without really changing the recommendation that you would give them. That is a data drift. So you need to watch out for the data drift. And at some point, some of this may lead to people actually changing their behavior. Just as an example here, when DoorDash consumer preferences shift towards more organic and healthy meals, then they need to have a different set of restaurants, or even the restaurants might have to change with more of those organic options, for example. So that's a concept drift because you're changing the decision. And then sometimes you're no longer interested in a particular decision, you're into a totally different one. So the target variable itself changes. That's called a target drift. And this happened during the COVID time. There were a lot of ghost kitchens. So again, people were not allowed to eat in restaurants, sit in and eat. So there were ghost kitchens that were appearing, basically people's homes, and they were delivering the food. So now you have a very different kind of a dynamic, and then you wanted to adapt to that. So these are some ways in which you need to be thinking about how the world is changing so that the models could adapt to it. So now, maybe the next 5 minutes or so, I'm going to talk about ethical and governance framework here.
And we actually have a few questions related to the foundational models and what you're speaking of.
Sure, yeah, we can take those and then just
So the first one is how multilingual are foundational models? So if they're at the bottom of a technology stack, it seems like being heavily biased toward English would impact their effectiveness when being used with other languages, even with translation interfaces in between.
Yes. A number of these models are essentially becoming multilingual. You're absolutely right that most of them started with English. Now there are sort of two, I wouldn't say divergent paths, two paths that people are following. Now there are a number of countries, European, Asian, African countries, who have their own foundation model initiatives where they are looking at their languages, right? So I know France, Germany, they all have their own foundation models. India has its models for various languages. China has its models. So in that sense, each country sees this as a national asset that they need to have and cannot be dependent on outside forces. So they are trying to develop language models of their own languages. So that's one trend. At the same time, you have some of these obviously large companies like OpenAI, Google, and also Meta making their models multilingual, right? So some of these players operate in multiple countries, so they have their customers in multiple countries, so they are also going into multi-language, multilingual models. So I would see that both would combine, right? So in an ideal world, and then you will be able to get a full access for these kinds of models. It's just a matter of time before those things happen, I think.
Thanks. Also, one other question came in about the decaying model. So what are some of the ways to measure or detect decay or drift in a model?
Yeah, so there are some very specific techniques, statistical techniques that people use, where you can look at the distribution of the input variables, the distribution of the output, and the relationship between them as to how it changes. Now, you may want to look at that periodically. The period may be a week, a month, sometimes it might be even within a day, right? So if you're using some of these for trades, right? So stock trades, then you may want to look at it within a single day period, right? So how the drift is happening. So there are very specific mechanisms to look at data drift. There are at least half a dozen different types of data drifts that are discussed in the literature. Similarly, for the concept drift and others, there are multiple methods. So, and what's happening in the data science or the AI world is these things are getting more defined, right? So early days, people were just very happy to just deploy the model. Now they're worried about how do I continuously train these models? How do I detect drift? But then there is also a subsequent one. Hey, I don't want to bring down the model. I want to keep the model running. And then you can do a switch over of the model between the old model and the new model, look very seamless. Or you can have multiple models serving different groups of people as well, and then test it out, right? So various kinds of mechanisms are developing. So there's a good theory behind it, but there's also a good number of tools that are behind it. And just to sort of mention, one of the tools is Evidently, which is an open source tool, which takes any of the external models, but you can pump the data there, and that'll do the drift calculations, for example.
Thanks. That's all we have at the minute.
Okay, cool. I know we're a little bit short on time, but I'm going to just quickly go through the issues, right? So I don't want to leave without talking about some of the negative effects which need to be addressed. So bias is one of the biggest things. So this is an example of Apple Card and Goldman Sachs. When people talk about bias, there are certain protected variables that they cannot use. So in this particular case, what happened is that Steve Wozniak, who is the one of the founders of Apple, and his wife both applied for this card, which was an Apple card sponsored, jointly branded with Goldman Sachs. Now he got a higher a credit limit than his wife, even though both had the same assets, right? So they share their assets. It was the same assets, but he got a higher limit, and that became a big news that the model was discriminatory, right? So of course he's in Apple, and the Apple Card was doing it. It's not as if it was deliberate. There was no gender column there, and it was discriminating based on that. The challenge is sometimes these variables, these protected variables, there are other variables that correlate to that, and that might be used, and the system might be biased. And the challenge with some of these things is some companies, as in this case, they don't even keep the protected attributes. The protected attributes are like gender, age, or ethnicity, and so on. Because they don't keep it, they can't even check for it. So they get into some interesting situations. This is an example. Another example that sort of we discussed very extensively in the class, or sort of raises some of the societal issues, is the machine bias. Machine essentially institutionalizing the bias that as humans we might have had, right? So in this particular case, it's a system called Compass that the US judicial system is using to see whether someone should be held in jail or can be let go on parole while awaiting trial. And the system was actually unduly discriminating African Americans, and especially African American women, was giving a much higher score. So there are various ways of measuring what is called as recidivism, and they found that it was definitely discriminatory. What was interesting in this case went to court, and the courts essentially and the company that built it, it was not the public sector that built it. It was a system that was procured, and they basically claimed that we built it according to specs, and the spec was maximize accuracy. When you maximize accuracy, sometimes you have false positives and false negatives. And their claim was, we can't be held responsible for false positives or false negatives. We were asked to maximize accuracy. Now, the false positives, as long as it occurs for everyone, maybe in a representative way, you need to just live with it. But if the false positive is discriminatory, in other words, if there are 10 false positives and 8 of them happen to be African American women are in that false positive set, and there are only one African American male and one Caucasian male, then that's not representative of the population that they use. So then that becomes discriminatory. So it's an interesting issue. And then we studied quite a lot about it. There's quite a lot written about it. This system is actually still being used, but with much more constraints and and oversight. So this is one of the very famous cases.
And
We all know. Yeah.
We've got a question related to this. So in the context of utilizing a pre-trained LLM, how are we able to effectively identify and mitigate biases presented in the models? And especially given that we didn't develop or train the models ourselves, what steps or techniques can be implemented to address the biases detected during deployment? And additionally, how can we balance the need for performance and ethical consideration when fine-tuning the models for our specific cases?
Yes, yeah. No, great question. So there's a lot of techniques. They call it guardrails, and the guardrails literally as a guardrail, they're when the input comes in from the LLM, you can grab that and you can write your own code to check it, right? So and that's something lots of organizations are doing. So for example, if someone says, "Hey, tell me how to make a bomb," right? So we probably don't want an answer, even though the LLM can answer it. So you can track the questions coming in and then allow only certain types of questions and then reply back. And that's what you see many of the LLMs do. And you can add more to that when you build your system, right? So using an LLM. Now, you can also do that on the other side, right? So the other side of the track where you're getting the information from the LLM, but before you give it to the user, you are doing some checks. So people are doing checks before, doing checks after, and that way you can at least control some of that. Again, you can't avoid everything. There are ways in which people can fool the system. So we study how people fool the system and how do you create a defense mechanism. So very similar to the cybersecurity arena, right? So that's what is happening in AI, much more involved in some of these applications. So given the time, what I'm going to do is just do a few things and then stop here. So this is deepfake. So again, an example of something that happened in Pentagon, where there was a fire, and of course it caused a lot of psychological angst, and it was discovered it was a prank. Now, it's fine, it was a deep fake prank, but if you look at how the stock market behaved, the stock market went up and down. Now, someone was perpetuating this thing, obviously made money, but quite a lot of people, you and me, lost money. And that's happening today, right? So it might be a simple thing, and there could be many more of these things coming. There are a number of these deep fake kind of situations for misinformation, disinformation, for gaining financial resources, as you see here. And that's also quite a bit of the dangers there. So with all of that, again, there's a number of these, and I don't think I can do full justice. I'm going to just go to just one slide and finish it, just looking at future trends. The risks, as we have been talking about, is probably one of the major areas of work and research. And you see a number of things on the right-hand side here. And the way that I see the thing evolving, we are looking at large language models, but we are also looking at small language models. So there's a huge amount of interest in that. Especially you can train these models with very concentrated information, like what you typically go through in a university setting. They're better to train these systems. Multimodal models, as I mentioned. Then the other trend that you are seeing is the combination of the old world, the 60 years of work that AI has done, is now combining with the generative AI part, right? So, and that's very exciting. So all the things that reasoning, planning, and all of that work that we were doing in the 70s, 80s, 90s, now that can be brought within the LLM mode. That's leading to what's called agentic technology, agents, multi-agent systems. And that's one of the biggest things that people are working at. And again, now it's different. Earlier, we were programming it. Now we are conversing to create agents. So conversation is the new programming paradigm, right? So, and again, Microsoft and others are pushing that. So earlier you used to know, you had to know a computer language to be able to do things. Now you just need your own imagination. Even that you can borrow a little bit from ChatGPT and the Anthropics, but now you can converse with the system to be able to build these systems. And that's what's making it exciting. And then, of course, there is a huge advancement in hardware, special purpose hardware. AI hardware, edge hardware. And again, on the other side, there's a number of things that one of the biggest challenges with the large language models is it consumes a lot of energy, a lot of compute, therefore a lot of energy. And there's a whole movement around green AI. And of course, the democratization of AI. These are all future trends to watch out for in the next couple of years. So with that, I'm going to stop, and I'm probably over by a minute here. So let me just stop here.
Thank you very much, Anand. Are there any other questions coming in? Feel free to use either the Q&A or the chat function as well.
So all I can say, feel free to jump into the question. So I think if you are deciding what you do, I think it's, to me, been in the industry for 35 years, it's a no-brainer, right? So AI is the thing for the next 20, 30 years, right? So as they say, AI won't take away jobs from humans, but people who use AI will take away jobs from people who don't use AI, right? So I think having some kind of a AI, either a full-fledged AI degree or just AI as an add-on, right? So that's the other thing. So every biologist, every agricultural scientist, right? So every engineer needs AI. So it's more like statistics. So you need that no matter which engineering discipline or which humanities discipline you're using, you need AI. So in that sense, I think to me, at least, it's a no-brainer that you should all become very conversant with AI. Either you do a degree or not, getting conversant with AI is almost a must.
And one question here is, how do you think information systems would be affected by generative AI in a general sense?
Yeah. So what we are seeing is AI is essentially penetrating every industry, and same thing with information systems, right? So as I said, it's the convergence of information systems, data, and information systems have always used data, but now the use of data is in a slightly different way as well. You need streaming data, and AI is penetrating there. So the way it changes is that instead of you programming things, you would still be working in information systems, but conversing, using AI to build better information systems, more reasoning systems. You'll be doing that, right? That's what we are seeing. So as information systems, AI is going to be embedded, very similar to the software engineering side and all the other disciplines, or even bioengineering, civil engineering, everything has AI embedded into it.
Excellent. Well, I think that's time for us. And I want to thank you very much for presenting for INFOcon 2024. For those of you who want to rewatch a non-session or hear any of the other presenters as part of INFOcon 2024, these sessions are being recorded and they will be posted to the INFOcon website and YouTube channel. So keep an eye out on your email for access to all of that. So Anand, thank you. Feel free to share any last final word before we close it out.
Thank you very much. Thanks, everyone.
All right. Take care, everybody. Thank you.